given here. Volume of solution, that is 500 ml, very fine thing. One molarity of the solution is given, and we have right. So here, wait a second. Molarity is what? Molarity is moles of solute. What is the solute here? That is H2SO4 upon volume of solution in liter, right? So for the moles, here moles are not given, but 49 gram of H2SO4 is given. So mole is what? Given weight upon molar weight. So what is the given weight? That is 49 upon what is the molar weight of H2SO4? When you will calculate, you will get as 98. Now I want to keep the volume in liter. So this is 500 ml. So it will become 0.5 liter. Okay. So this will become just like this. Now when you will calculate, you will get 1 molar solution. Okay. Now let's proceed on to the next question. Next question is, calculate mass of H2SO4 in 500 ml of 1m solution. First of all, I would like you people to try this. Then you should match your answer with mine. I hope you people must have tried. Okay. Now you tell me that what are the information given here. Volume of solution, that is 500 ml. Very fine thing. One molarity of the solution is given, and we have to calculate the mass of H2SO4 that was used in preparing this solution, right? So molarity is what? That is moles of solute. What is the solute here? That is H2SO4 upon volume of solution. So the volume of solution we have to keep in liter. Here it is 500 ml. So this will be 0.5 liter. So the moles will become 0.5 H2SO4. This is the moles. Okay. Now we want to calculate the mass. So this will become moles into molecular weight of H2SO4. So moles 0.5 into molecular weight, that is 98. On calculation, you will get 49 gram of H2SO4. Means we need to put 49 gram of H2SO4 in 500 ml to get 1 molar solution. Okay. So these questions were related to the basic information of the concentration terms. Okay. Now the next question which we are going to discuss, actually it will be related to the concept of dilution. Now to understand the concept of dilution, we don't need to read a lot of books and a lot of theory, because they will make your task a little bit of difficult. You understand it by a case. Suppose the question I give you is that if 500 ml 3mNaOH solution is mixed with 500 ml water, to form a resulting solution. Calculate the molarity of NaOH in resulting solution. Right? Now, what do you need to find? You need to find the molarity of NaOH in resulting solution. That means you need to calculate the moles of NaOH upon volume of solution in liter. Now, first of all, we were having 500 ml 3mNaOH. So, what were the moles which we were having? That is molarity into volume. Molarity is 3m into volume. I need to write it in liter. So that will be 1.5 moles. Okay. Now, what you can see that we have added only water to this container. We have not added any kind of moles of NaOH. So that moles will remain constant. So here in this formula, I can write 1.5 moles of NaOH upon volume of solution in liter. So initially we were having 500 ml and later on 500 ml were added. It means 1 liter. So that will become 1.5 m. Okay, that will be the molarity of the resulting solution. So what is the SOP? What are the standard methods that if moles is not increasing? First of all, calculate initial moles. After dilution, calculate total volume. Then write in the form of moles by volume. Okay. Now let's discuss the next question. Question is, calculate volume of water added to 2m 100 ml HCl for making 0.25 m resulting solution of HCl. First of all, I would like you people to try this question. Now, to understand such questions, you need to understand that what is happening. Molarity is changing, right? The thing is this, molarity is changing. Now, molarity, as it is dependent on moles and volume, so it can change in two conditions. Either you change moles by adding or removing, okay? Or you change the volume. So in this question, what is happening? That volume of water added, that means volume of the solution is changing. Fine. And that change we need to calculate. So let's pay attention. That means moles are constant. So first of all, take the initial scenario. Initial scenario is like 2 moles 100 ml HCl. Now from here I can calculate the number of moles, and number of moles will be molarity into volume. 2 is the molarity, volume in liter. So it will become 0.2 moles. Just now what I told you, that moles are not changing. We are just adding the volume. Okay, volume of water. So we will see the condition after addition of water. So it will become molarity is equal to moles by volume. We need to calculate that volume. Molarity is 0.25. That is the final molarity. In is equal to moles, that is 0.2 upon volume. So this will become 0.2 upon 0.25. So it will become 0.8 liter. Initially we were having 100 ml. Okay. And here I am having 800 ml. So how much water I have added? That is water added. You write. That is 800 minus 100. So it will become 700 ml. And that will be the correct answer for this question. So up to here, what was happening? That we were not adding solute. We were just increasing the solution's volume by addition of water. That was the case of dilution. Next, we will see when we will add solute. When we will add solute. In this, we will have two scenarios. Let's see what. When the two solutes we have added, either they can react or they can not react. Suppose they are not reacting, so it will become
crowded classes. These gaps go unnoticed. With one-to-one mentoring, chemistry becomes logical and real improvement begins.